Chemistry videos, balancing a chemical equation. Once a chemical reaction has been created, the next step is to balance the atoms on each side of the reaction arrow. There are certain rules you must follow. First, you always balance the metals. No questions about it. Make sure that all the metals on both sides of the reaction arrow are always balanced first. Once this is done, go back and rebalance the non-metals. Now, the non-metals, as we know the stair step on the periodic table, so the ones on the right side are the non-metals and everything on the left is the metals. When you go through and you balance the non-metals and that changes the metals, then go back and rebalance the metals. After all the metals and non-metals have been balanced and rebalanced, then you will balance the hydrogens. The very last thing you will do is balance the oxygens. If you follow this format, then it should be fairly straightforward. You won't have too many problems. Here's a little special tip. If you're having trouble getting the equation balanced, you probably have an incorrectly created compound. Go back and check your compounds, make sure there's no Mr. Brinkelhoff rules, and that everything has been balanced accordingly. Make sure you remember the polyatomic ions and balance everything accordingly. Okay? That's why we have the mandatory pass first exam, because if you can't get that, this is going to cause some problems. Now here's a little practice. We're going to go through several of these here and see if we can't get this done. We're going to write the equation and then we're going to balance it. So it says here I have aqueous ammonium nitrate. So if I remember, ammonium is NH4 and it has a +1 charge. So I'll write that up here. I usually like to do that. And then nitrate is one of my polyatomic ions and it has a -1 charge. So putting those together, I just need one of each one of them. Now it says I'm going to put it into a solution, aqueous means solution, of sodium. So sodium has a +1 charge, and phosphate is one of my polyatomic ions and it has a 3- charge. So that means I got to have 3 sodiums for every 1 phosphate. So we're going to add this to sodium. I need 3 of them. Phosphate. Okay? Reaction arrow. Now, once again, if you have trouble determining what type of reaction it is, go back and review the types of reactions, identifying type of reactions video to get this down. But if I take a look at this, I can see that I have 1, 2, 3, 4. I have 4 elements, so this is going to be a double replacement reaction. So when I write this, I'm going to take my ammonium, and it's going to attach itself to the phosphate. Now the charges, as always, have to remain the same. We know the phosphate has a -3 charge. We know the ammonium has a + charge, so we have to be able to write this like this, and I'm going to need 3 of those there. And then my sodium is going to be attached to my nitrate, and they're a +1 and a -1, so I don't need anything extra there. So I've got ammonium nitrate plus sodium phosphate is going to create ammonium phosphate plus sodium nitrate. Okay, so we're going to go to the next page, we'll rewrite this, and we're going to work on balancing it. So we had ammonium nitrate plus sodium phosphate created ammonium phosphate plus sodium nitrate. So there's our chemical equation. Now we have to work on balancing it. Okay? So let me get myself another color here and let's go to blue. Okay? So, first thing I want to do is go through and look at my metals. The only metal I have on here first is my sodiums, okay? Now, once I have my chemical compounds made, I can never change the subscripts. These guys have got to stay the same all the time, okay? Never change those. All I can do now is add big coefficients in front of it. So the first metal I see is I've got sodium here. I got 3 of them over here, but only here, oh, I only have 1. So I got to put a big 3 in front of that. So now I have 3 sodiums on this side of the reaction arrow and 3 sodiums on this side. Now that's my only metal. So now I work on my non-metal. So let's just start the very front of the equation here. We'll work on the ammonium. I have 1 ammonium here. I have 3 ammoniums over here. That's not good. I need to put a big 3 in front of this over here. So now I have 3 ammoniums and I have 3 ammoniums. When I added that 3, that meant I also had 3 nitrates, okay? When I come over here, I say, okay, well, I have 3 sodium, and I already have 3 nitrates, so they're balanced. Now I look down, and I've already got my sodiums balanced, so I look at my phosphates. I got 1 phosphate here, I got 1 phosphate there. So according to my equation, I am now balanced. I have 3 moles of ammonium nitrate plus 1 mole of sodium phosphate creates 1 mole of ammonium phosphate and 3 moles of sodium nitrate. Now let's try a different one. Okay, so here let's take magnesium reacts with aqueous copper 1 nitrate. Now copper 1 means that it only has a +1 charge. Nitrate, we know, is a polyatomic ion. It has a -1 charge. Magnesium, it sits by itself. So anytime I see something sitting by itself, I got to say, okay, is this part of Mr. Brinkelhoff? And I see, no, it's not, so it's okay to write it by itself. So we're going to write copper nitrate, because it is copper 1, and those balance out, plus magnesium is going to create. Now, as we talked about before in types of reactions, we have 3 different elements here. Okay, we've got 1. We keep this one as a whole unit, the polyatomic ion together, and here's the other one 3. So this is a single replacement reaction, which means the magnesium is going to come over here and replace the copper. So I'm going to have magnesium nitrate plus copper. Now, magnesium has what when it's an ion? It is a 2+ charge. So nitrate here is a -1 charge, so I'm going to need 2 of them. Okay, so here's my equation. Copper 1 nitrate plus magnesium will create magnesium nitrate plus copper. So now let's balance it. I start with my metals. First metal here is copper. I got 1 on this side, I got 1 on this side. Okay, so that means, okay, coppers are done. Let's go to magnesiums. I got 1 on this side, I got 1 on this side. Magnesiums are balanced, but now I got to go to my non-metals, which is my nitrate. I got 1 on this side, I got 2 on this side. So now I got to come back over and put a 2 over here. I cannot change the subscript on the nitrate, I got to change it on the whole compound. So now I have 2 nitrates on this side to match the 2 nitrates on this side. So my copper now is no longer balanced, so I got to come over here and put a 2 in front of this. So now I have 2 coppers, 2 coppers, 2 nitrates, 2 nitrates, 1 magnesium, 1 magnesium. I'm now balanced and I can start the rest of my problem. Now this one here, as we've talked about, is going to be a combustion reaction, and we've talked about this, in class and also in types of reaction. Combustion reactions have to have oxygen, so they can, actually burn, because that's what we're doing, and then we only have carbon and hydrogen here. So a combustion reaction is always going to create carbon dioxide plus water. Okay, so there's my chemical equation for a combustion reaction. This part down here always is going to be the same. Okay, the only thing that's ever going to change is how many carbons and hydrogens, whatever we have. In here we have, actually this has been written wrong. This says propane, and it actually is octane. So somebody, myself, typed in the wrong name. But anyways, we'll use this as octane. Okay, so I've got octane here, so once again, I have any metals in here? No, so I go immediately to nonmetals. My first nonmetal here is carbon. I have 8 carbons here, okay, but I only have 1 carbon here, so I have to put an 8 in front of here, okay. Now I move down to the next one. I have my hydrogens, okay, I have 16 here, I have 2 here. How do I get 16? I'd have to add an 8 here. So now I have 16 hydrogens, 16 hydrogens. Now I move down to my oxygen. On this side I only have 2. On this side I have 8 times 2 is 16 plus 8 equals 24. I need 24 on this side, so that means I have to add a 12. So my final balanced chemical equation would be C8H16 plus 12 O2s is going to create 8 carbon dioxides and 8 water molecules. Review this as many times as possible. Always bring questions into class to ask them, but you need to be able to get comfortable at balancing a chemical equation, because that's the first part of the mandatory pass exam, is being able to create the equation and balance it, because the biggest part of each one of the problems on a mandatory pass exam is the actual calculation of how many moles to grams and grams to moles that we're going to be able to have, and that's part 2. So practice this as many times as possible, and never, never, never give up.